So now that I've given you the big picture view of the Executor framework, let's start talking about each of its key interfaces one at a time, starting with the simplest one, which is the Java Executor. This gives you a very simple way to submit new tasks for execution via the execute method. It's a very simple functional interface. Just means there's one method in it that decouples task submission from the mechanics of how each task is run. Each task that you submit to the Executor interface implements the runnable interface, and could, of course, also be a Lambda expression or a method reference, but you just have to make sure it implements the signatures expected by runnable, which is a single method that has no parameters and returns no result. So it's a very, very simple, also a very simple functional interface. You can think of runnables as being commands to execute. So those of you who have taken the CS 251 course, there's a pattern in the Gang of Four book called the command pattern, where a command encapsulates all the information that's needed to perform an action or trigger an event at some later point in time. So you can think of this as a command like run this command or execute this command. And you can also think about this as another pattern that appears in another book that started the patterns movement 25 years ago or so, called the Pattern-Oriented Software Architecture book, Volume 1. And in there's a pattern called the command processor pattern. And in many ways, the Executor framework implements the command processor more than it does the command pattern. The main difference between the two patterns is that command processor explicitly describes how to have a pool of threads or processes in which to execute commands concurrently. So basically, the command processor pattern is what the Executor framework, and especially the Executor interface, is allowing you to do. The Executor interface only supports so-called one-way task semantics. What does that mean? Well, it's actually quite simple to ferret out if you just look at the runnable interface. As you can see, runnable returns no result. So it only does one-way computations. You say, hey, Executor, run this or execute this runnable. So the runnable, of course, contains the computation. So it gives it to the framework, and the framework executes it, and there's no result coming back, at least no result coming back through some API that's part of the Executor framework abstraction using the Executor. You could have some other way to get results back, but that would be through side effects, not through a return value. So they're one-way tasks. So any kind of results you want to have, whatever they might be, have to be done through side effects. You can execute runnables in the Executor interface or via the Executor interface, either in a background thread or in the main thread, depending on how the Executor interface is implemented. And there's actually something called a single-threaded executor. So if you take a look at the Executor's utility class, there's a method called new single-threaded, I forget what the name is. I don't think it says pool, because it's not a pool. Single-threaded executor. And in that particular case, there's only one thread, and it's just going to go ahead and run in that single thread. So that's Executor in a nutshell. There's really not a whole heck of a lot behind it, which is both a blessing and a curse. If you have very, very simple thread pool needs, Executor will do the job. No muss, no fuss. However, it's so simple it could be considered simple-minded.